Voyager's passage by Jupiter accelerated it towards a close encounter with the planet Saturn. Saturn's gravity will propel it on to Uranus, and in this game of cosmic billiards after Uranus, it will plunge on past Neptune, leaving the solar system and becoming an interstellar spacecraft, destined to wander forever the great ocean between the stars.
In 2012, Voyager ventured beyond the solar system, stepping into the uncharted realm of interstellar space. 12 years on, its signal still reached Earth, but the data it sent had decayed into digital noise. NASA discovered the culprit: just 3% memory corruption, enough to blind the spacecraft across 15 billion miles. Alive but confused, Voyager posed a haunting question. If the signal survives but clarity fails, how can we trust what it reveals? The answer lies in why this historic journey only grows stranger the farther it travels. On August 25, 2012, Voyager 1 crossed a boundary that had existed only in theory. The helipper, the outer border of the sun's influence. At nearly 122 astronomical units from Earth, the instruments registered a sudden spike in electron density, an 80-fold jump that could only mean one thing. The probe had entered a new domain. Cosmic ray detectors, too, recorded a surge as particles from the galaxy flooded in, no longer blocked by the solar wind's protective shield. For decades, scientists had pictured this region beyond the helipper as a kind of cosmic quiet. The expectation was straightforward. Once past the turbulence of the solar system's edge, Voyager would coast into the local interstellar medium, a place governed by steady, undisturbed conditions. Quick pause before we drift any farther into interstellar space. If you enjoy these slow, unsettling deep dives into real science at the edge of the unknown, take a second to like the video, subscribe to the channel, and tap the notification bell so you don't miss future uploads. It's free, it helps the channel more than you might think, and the algorithm absolutely eats this stuff up. All right, back to Voyager. In theory, the magnetic field should align with the broader galaxy. Particle densities should level out and the background should be uniform, almost serene. This was the scientific baseline, the clean slate against which every new signal could be measured. Project scientists like Ed Stone described it as entering a wholly new environment, one where the sun's influence faded and the galaxy itself took over. The hope was that data from this region would be clear, interpretable, and free from the complications of the solar wind. The stakes were high. For the first time, humanity had an outpost sampling the true conditions between the stars. Every reading promised insight, and every anomaly could be traced back to a well-understood cause. That was the expectation. Reality, as Voyager pressed farther, would prove less simple. In November 2023, the stream from Voyager 1's transmitter remained steady, a clean, unwavering carrier slicing through more than 15 billion miles of void. Command still reached the spacecraft. The Deep Space Network could lock onto its signal just as it had for decades. But the data inside that signal was unintelligible. Instead of packets filled with scientific readings and engineering logs, the downlink was a torrent of digital noise, a jumble that made no sense to ground systems. The spacecraft was alive, but its voice had turned to static. Engineers at JPL faced a confounding paradox. Every indicator said the probe was functioning, yet the telemetry, the only way to know what Voyager was sensing or how it was faring, was scrambled beyond use. This was not a gradual fade or a simple hardware death. The flight data subsystem, the part of Voyager that packages and sends all science and engineering data, had suffered internal corruption. I'd really like to know how you read this moment. Do you see Voyager's silence as a purely technical failure, or as something more symbolic, a warning about how fragile our reach into deep space really is? Share your thoughts in the comments. We genuinely want to read your opinions, especially thoughtful, constructive ones. We try to read as many as possible, and when we can, we reply or even use great insights as inspiration for future videos. Somewhere in its small, ancient memory, A fault had twisted the outgoing information into nonsense. The team could not just reach out and swap a chip. Each diagnostic command took nearly a full day to travel one way, with another day for the reply. Every attempted fix meant waiting for the round-trip echo, hoping for a hint that something had changed. In this deep space standoff, the engineers were forced to become forensic investigators, sifting through patterns in the noise, searching for the root of the incoherence. The spacecraft was still there, still listening, but its story was locked behind a wall of corrupted code, and the only clues came from the fragments that survived the journey home. A single command sent in early March 2024 set the recovery in motion. Engineers at JPL crafted a software poke, a prompt designed to force Voyager's flight data subsystem, here called FDS, to spill its entire memory contents byte by byte across the gulf of space. The round trip for that signal stretched over 44 hours. When the reply finally arrived, it was not the usual torrent of digital noise. Hidden in the mess was a full forensic dump of the spacecraft's memory. Decoding that dump took days, but the pattern was clear. About 3% of the FDS memory had gone bad. The damage was not spread evenly. Instead, one chip responsible for both code and variables had suffered the brunt with bits stuck on or off, corrupting crucial instructions. The team could not simply overwrite the faulty code. No single block of spare memory was large enough to hold everything intact. They divided the working routines into smaller pieces and threaded them into healthy sections scattered across the FDS. Each relocation required its own set of commands, each with its own delay. Weeks passed as the engineers rebuilt the probe's operating brain patch by patch in a process that felt like remote surgery on a patient who could only signal back once a day. By mid-2024, the gamble paid off. Science and engineering data began flowing again, partial but real. The probe's voice, once reduced to static, regained coherence. Yet, the fix underscored a deeper truth. Even when ingenuity wins, the system grows more fragile. Every new mile out makes the next repair harder. The data is back, but the certainty is thinner than ever. In mid-2020, Voyager 1's instruments caught something that should not have been there, an abrupt, persistent jump in both plasma density and magnetic field strength. The readings did not settle back to baseline. Instead, the environment around the spacecraft stayed elevated about 30% higher than before, and it has remained that way for more than 5 years. Plasma wave data picked up irregular whistles, while the magnetometer logged a steady plateau, not the gradual smoothing that models had predicted. Project scientists traced this to what they called Pressure Front 2, a compressive structure moving through the very local interstellar medium. Unlike earlier shocks, which faded in months, this one just kept going. The cause is not fully pinned down. Some NASA materials link it to old solar eruptions, their effects finally catching up after decades in transit. Others point out the structure does not match classic shock signatures. What is clear is that interstellar space, at least in Voyager 1's neighborhood, acts less like a calm void and more like a place with weather dynamic, layered, and still resisting easy explanation. Voyager's ability to keep sending data depends on hardware that is now nearly half a century old. The probe's thrusters responsible for keeping its antenna pointed at Earth have become a particular concern. Years of firing have left residue in the fuel lines, gradually reducing efficiency and raising the risk of clogging. In 2024, mission controllers shifted operations to backup thruster sets to avoid pushing the primary set past its limits. Each maneuver now comes with heightened scrutiny. Every pulse draws on a dwindling reserve of reliability. Power is another constraint tightening around the mission. The radioisotope thermoelectric generators lose output every year as their plutonium fuel decays. By 2025, the team had to shut down more scientific instruments to keep the most essential systems alive. Choices about what to turn off are not just technical, they are existential. Each shutdown narrows what Voyager can sense, trading breadth of discovery for sheer survival. The probe's continued journey now depends on a shrinking toolkit and every new problem means making do with less. As the spacecraft presses deeper into the unknown, its own fragility becomes part of the mystery it is meant to explore. Project scientists now face a puzzle with no tidy answer. One interpretation traces the persistent pressure front to a solar eruption, an ancient coronal mass ejection launched decades ago from the Sun, only now catching up with Voyager as a slow-moving wave. That explanation fits parts of the data, but the sheer duration and structure of the anomaly suggests something more layered. Another group sees evidence for a thick structured boundary zone, an extended region where solar and interstellar influences mingle, creating gradients and pileups instead of a clean exit. There's also the possibility that what Voyager is seeing is not truly interstellar at all, but rather a transitional zone shaped by the heliosphere's fading reach. And as power dwindles, likely running out between 2030 and 2031, each instrument lost narrows the window into these mysteries. The ranking of uncertainty has shifted. Some causes are likely, others plausible, but none fully close the case. The next anomaly may come with no warning and perhaps no explanation at all. Right now, Voyager's signal threads through a region more unpredictable than predicted. Each new anomaly is not just a glitch. It is a reminder that our deepest models break first at the edge. Out here, certainty is provisional. The frontier stays weird. And if you want to keep following missions like Voyager, stories where engineering, mystery, and the unknown collide, the best way to support the channel is simple and free. Leave a like, subscribe, and turn on the notification bell so you never miss the next deep dive. And if you know someone who loves quiet, unsettling space science, share this with them. Voyager may be fading, but the questions it leaves behind are only getting louder.